Happy day, everyone. This is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Please, before we go into solving a particular problem today, do not forget to like, share, subscribe, and click on notification button to have more of my video. Now, in my last video, I discussed about what is Kirchoff's laws are all about. We talk about the current law and we talk about the voltage law. So in this video, we want to use Kirchoff's law to solve problems that we have here. The question says, given the following electrical circuit diagram that we have here, as the situation is below, we are to find the currents across each of the resistor as given, and then the cell as arranged in the circuit. Now, what we are going to do now is this. I'm going to take, according to Kirchoff's law, I'm going to start from here. So let me say the current I is moving from here. So this current I will move and reach this particular junction. So when the current I reach this junction, it's going to break into two, into this branch. Let's say the one that will go through this side of the branch, let's call it I2, and the one that will go into this side of the branch, let's call it I1. So that means current I2 is entering resistor 10 ohms, while current I1 is entering resistor 30 ohms. So we have these two cells in this particular circuit. Now, according to the voltage, according to the Kirchoff's current law, it says that the total current entering this junction must be equal to 0, or the sum of current entering this junction must be equal to the sum of the current leaving the junction. So this I is entering, so the I will be equal to I2 plus I1. That's the Kirchoff's current law. So take note of that. Now, the second law is the Kirchoff's voltage law. So I'm having three loops in this diagram. This big one is a closed loop, number 1. Then I have this loop, number 2. Then I have this loop, number 3. So let me start with this particular loop. I'm starting from here. I'm going this way, down like this. So let's call it loop A. I want to go around the loop. If I'm starting from here, this current is moving from the low terminal of the cell to the high terminal of the cell. So the cell, there is a voltage rise here, because from the negative to the positive. So there is a voltage rise. So I'll write it as 10 volts. Then when the current move to this place around the circuit, here the value of the current will be rising, because the current is moving across this 30 ohms resistor. So the current is dropping. I mean, the voltage is dropping. So I'm going to have minus 30 I times I1, because voltage is current times resistor. So this current times resistor is 30 times I. But because current is moving along my movement of the loop, is going to be negative. Now, there is no other components here, so the whole of this one, according to Kirchoff's voltage law, must be equal to 0. Now, here now I can have my I1, making I1 subject to the formula. So I1 will now be minus 10 divided by minus 30, which is equal to 0.33 ampere. So that means I1 is 0.33 ampere. Now, for the second loop here, I want to move around this loop in this way, and then if we start from here, there is a voltage drop across 10 ohms resistor, and that voltage is going to be minus 10 times I2. So for this loop B, I have, when I move like this, it's going to be minus 10 times I2. That's a voltage drop. As I move towards this particular cell, I'm moving from the positive terminal of the cell to the negative terminal. So there is going to be electromotive voltage drop across this particular cell that I have here. So it's going to be minus 12. Now as I move in this way to this particular place, there is a voltage rise, because here is a positive terminal. As I move with this I1 to negative, so as I'm moving back here now, I'm moving from negative to positive, so there is a voltage rise. So it's going to be plus 30 times 0.33, because the reason being that this 0.33 is my I1, so everything is equal to 0. So we can now solve for I2 from here. I have minus 10 I2 minus 12 plus 30 times 0.33 will give us 9.9. Everything equal to 0. So making I2 the subject of the formula, everything will result to minus 0.2 ampere. So that means the I2 is equal to minus 0.2 ampere. And then from this first equation that I have here, I can have the value for this current that is leaving this particular 10 volts cell. This is total current there. So my total current now, I is equal to I1 plus I2, which is equal to 0.33 minus 0.2 ampere. So 0.33 minus 0.2 will give me 0.13 ampere. So we can equally find the value of voltage drop across the 30 ohms resistor and across the 10 ohms resistor. So the voltage drop across the 30 ohms resistor is equal to the current across the 30 ohms, that is I1 times the resistor of this 30 ohms. So I'm having I1 is already obtained at 0.33, so I'm having 0.33 times 30. So 0.33 times 30 will give us 99. No, it's going to give us 9.9 volts, which is approximately equal to 10 volts. So the voltage across the voltage drop across 10 ohms resistor, I can write it as V subscript 10, which is I2, because current I2 is passing through 10 ohms, then times 10 ohms resistor. And because the voltage drop here is negative, so I have it as minus 0.2 times 10, which is minus 2 volts. I believe that you must have learned one or two things as regard Kirchoff's voltage and current law. Thank you for watching my video. Please, once again, do not forget to like, share, subscribe, and click on notification button to have more of my video. This is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Have a nice day. Bye.